Our group will present about free space optic based OCDMA for indoor optical wireless. For introduction, an optical wireless communication system depends on radiation to carry information in free space with wavelength ranging from infrared to ultraviolet with the visible light spectrum. Then OCDMA is based on the principle that codes are mapped to the identities or address of user following a code user relation. A basic optical wireless system consists of the light source, free space as the propagation medium, and light detector. The source output pass through an optical system which is to control the emit radiation and to ensure that the transmitter is eye safe into the free space. The received signal comes through an optical signal which is an optical filter that rejects optical noise. LED are the favored light source due to the relaxed safety regulation, low cost, and high reliability matched to the laser diode. Pin photodiodes are used due to the lower cost, tolerance to wide temperature fluctuation, and operation with an inexpensive low bias voltage compared to a valence photodiode (APD). The problem statement from this mini project is to implement code was complex and difficult to configure. It was from previous research. Then the OW communication channel is not classified as the presence of direct path between the transmitter and receiver.
The objective of this mini project is to design OCDMA system using ZCC code. Next, to simulate the system using OPTICIS and to analyze the simulation result of free space optic based on OCDMA for indoor optical wireless. The project scope of this mini project is to analyze the free space optic based on OCDMA for indoor optical wireless using ZCC code. The simulation is done on OPTICIS 7.0 and the result is being analyzed from the bit error rate and signal power value. For the block diagram, the input electrical signal will be passed through the modulator and the signal will be modulated to the light source and passed through the optical system, and the output will be output optical signal. This optical signal will be passed through the medium, which is free space, and will be go through the optical system, pass to the light detector, and the amplifier will be amplify the signal, and the output will be in terms of electrical signal.
The code development for ZCC code is used in this mini project is represented in metric K, row, and C as column. ZCC code demonstrates an excellent performance of bit error rate (BER) since it was designed in such that no cross-correlation between the user. The ZCC code has flexibility in number of weight consideration. The ZCC code, which is K as row and C as column, represent number of user and minimum code length as the figure shows below. This is the value of ZCC code that we use in our simulation for this mini project.
Design and methodology. In order to design an indoor OCDMA system based on ZCC code, encoder and decoder design is also implemented. These are our simulation. The main component that we use in this design are LED, WDM, DMARCs, idle marks, photodetector, WDM marks, match sender modulator, and bit error rate eye diagram analyzer. At the transmitter part, LED is used as a broadband source which is sliced into narrow spectrum width of 0.8 nanometer by using DMARCs. The mesh sender modulator was used to modulate each other data into an optical signal. All user signals are combined and sent through the optical fiber. The filter optical signal are then converted into electrical signal using photodiode. For result and discussion, we found that the circuit can reduce the quality of signal that be expressed by the bit error rate, improving the bit error rate and SNR of the system. The difference in chip power will decrease the system performance. This is the bit error rate data, and the graph represents the bit error rate. This is the power rate data, and the graph represents the power rate.
For the conclusion of this research, we have investigated an indoor optical wireless communication system based on OCDMA technology and using ZCC code. Zero cross correlation code has been constructed in simple algebraic way, and the effect of noise varies at different data rates, and performance of OCDMA system is degraded as the number of simultaneous users increase, especially when the number of users is large.